Final exam review, part 3, probability. 14. Lennox Lewis is considering a certain stock. After careful research, he determines there's a 40% chance of making $10,000, a 10% chance of breaking even, and a 50% chance of losing $5,000. Find the expectation of the stock purchase. So to find the expectation, you take the probability that an event will occur and multiply it by the amount to be gained or lost if that event actually does occur. If there's more than one event, you'll take the probability of that second event times the amount to be gained or lost if that second event occurs, plus the probability of a third event occurring times the amount to be gained or lost if that event does occur, and so on. Well, in this problem, there are 3 events. He could make 10,000, break even, or lose 5,000. So to find the expected value, the probability that he'll make 10,000 was 40%. So as a decimal, that would be 0.40 times the gain of 10,000. Now the probability that he'll break even is 10%, or as a decimal, 0.10. And if he breaks even, there's no gain or loss, so it's 0. The probability that he'll lose 5,000 as a decimal is 0.50, and since it's a loss, it'll be a negative 5,000. So if we multiply this out, the 0.40 times 10,000 plus 0.10 times 0 plus 0.50 times a negative 5,000. You see that there's a $1,500 average gain per investment. So sometimes he gains 10,000, sometimes he breaks even, sometimes he loses 5,000, but if he averages all those gains and losses together, the average is a gain of 1,500. 15. A jar contains 15 red jelly beans, 25 yellow jelly beans, and 10 black jelly beans. 1 jelly bean is selected at random. We want to find the probability that the jelly bean is red. Now, for probability, we usually express that as a fraction or a decimal. Here we want a simplified fraction. So it would be the number of favorable outcomes over the total. So there's a total of 50 jelly beans. Out of those 50 jelly beans, 15 are red. Then I want to reduce that. So 5 goes evenly into both 15 and 50 to 3/10. Now remember, when it's a probability, as a fraction, it would just be favorable over total. Now we want to determine the odds against selecting a black jelly bean. So odds against, we usually express that as a ratio of unfavorable outcomes to favorable outcomes. So unfavorable would be not black. Favorable would be black. So there are 10 black jelly beans and a total of 50 jelly beans. So 50 minus the 10 black would be the number that are not black, 40 to 10. So there's 40 jelly beans that are not black to 10 that are black. That's the odds against getting a black. Now, ratios, like fractions, have to be simplified. So I can see that 10 divides evenly into both the 40 and the 10. So I have 4 to 1. That's the odds against a black jelly bean. 16. Suppose you draw one card from a well-shuffled deck of 52 cards. What's the probability of drawing a face card? Now, a face card consists of jacks, queens, and kings of all four suits. Jacks, queens, and kings of hearts, diamonds, spades, and clubs. So, to find the probability of a face card, if we're going to express that as a fraction, it's going to be the favorable outcomes, the outcomes that are favorable to face cards, over the total. So there's 12 face cards in the deck out of the 52 cards in all. So I can reduce this, since we want a simplified fraction. 4 goes evenly into both 12 and 52, so 3/13. So the 3 represents the favorable in the reduced form. The 13 represents the total. So determine the odds in favor of selecting a face card. So odds in favor of would be the favorable outcomes to the unfavorable outcomes. So I could make this a little bit easier for myself by using the reduced fraction. There were 3 that were favorable, and if there are 13 total, we'll take the total minus the favorable, and we'll find out that there's 10 unfavorable. So the probability of selecting a card that's not a face card for this, I can use the complements formula to find the probability that an event will not occur. All we have to do is subtract the probability that it will occur from 1. So it's 1 minus the probability of selecting a face card. Well, that's 1 minus, we said the probability of selecting a face card was 3/13. Now I'll write that 1 as 13/13 minus the 3/13. So I have 10/13. For D, I want to find the probability of drawing a 4 or a queen. Now, or always tells us to add. So we use the addition formula. The probability of a 4 or a queen is equal to the probability of selecting a 4 plus the probability of selecting a queen. Now, if these events have any overlapping outcomes, we have to subtract the probability of both. We're selecting one card, a single card. The probability that that one card is a 4, well, there's 4 cards that are favorable to a 4 out of the 52 cards in the deck. The probability of getting a queen, well, there are 4 queens in the deck, so 4 cards that are favorable to getting a queen out of the 52 cards in the deck. If you're just taking one card, you can't get a card that's both a 4 and a queen. So we'd say that those events are mutually exclusive. It's not possible. So I have 8/52, and I'll reduce it. 4 goes into both 8 and 52. So 2 over 13. So we want to know what's the probability of drawing a spade or an ace. So that or always tells us to add. So we're using the addition formula. It would be the probability of getting a spade plus the probability of getting an ace. Now, if it's possible for both to happen at the same time, we have to subtract the probability of both, you know, if there are overlapping outcomes. All right, well, there are 13 cards that are favorable to being a spade out of 52. The 4 aces, so 4 cards that are favorable to an ace out of 52. Now, you're just taking one card, but it is possible to get a card that's both the spade and the ace if you get the ace of spades. So that is just one card. So keep the denominator, add and subtract the numerators, and reduce it. So 4 goes both evenly near both 16 and 52. So 4 out of 13. (16) 2 cards are selected from a standard 52 card deck with replacement. Find the probability of selecting 2 face cards. So that means we want the probability that the first card is a face card. We're going to put it back, shuffle the cards really well, and then the second card is a face card. So that, and then we have 2 parts to our experiment, first one and then the other. We're going to multiply, use the multiplication principle of probability. So for the first card to be a face card, well, there's 12 face cards out of 52 in the deck. If we put that card back and shuffle the cards, we've restored that deck to its original condition. So there's still 52 cards. And out of those 52, there's still 12 face cards because we put it back. So you can use your fraction calculator if you want and just multiply 12 fraction 52 times 12 fraction 52. And I get 9 over 169. All right, for 17. 2 cards are selected from the standard 52 card deck, this time without replacement. Find the probability of getting 2 face cards. That is, the probability that the first card is a face card Okay, we don't put it back. And then the second card is a face card. So our experiment has 2 parts. We want the first one to happen and then the second one to happen. So this is the multiplication principle. So for the first card to be a face card, there's 12 face cards out of the 52 in the deck. But if we don't put that card back, there's now only 51 cards. And that one card we didn't put back was a face card. So there's 11 face cards. So if we use the fraction calculator, 12 fraction 52 times 11 fraction 51, it should reduce it for us, multiply and reduce it to get 11 out of 221.